before we go to the next section, I just want to say something about last night's homework. This is guaranteed going to be one of the problems on the free response. The thing I was talking to you about yesterday. Suppose you have a tank, and let's say it starts with, what did I say yesterday? 40 gallons of water. But then, water is being pumped into the tank at a certain rate, and then water is being taken out of the tank at a certain rate. So, they might ask you questions like, at the end of 10 minutes, how much water is in the tank? So, the amount of water in the tank is equal to whatever you started with, 40 gallons. And then if this is the rate at which water is being poured in, how much water was actually poured in during the first 10 minutes? You do an integral from 0 to 10, right? This is last night's homework. But then water is being taken out. So how much was taken out at the end of the 10 minutes? Well, you gotta subtract. If you are given a rate to find out how much was done or accumulated, you do an integral. Okay, but they're also going to ask you additional questions like, how much water is in the tank at any time t? Not just at the end of 10 minutes, at any time. So how would you change this? How would you figure out how much water is in the tank at any time t? Take away the 10 and replace it with? Yeah, letter, a variable, t. And then they might ask you a question like, well, when will the tank be empty? Yeah, so when this is equal to 0. And of course, how do you solve any equation on your calculator? You make one side 0, which it is, and then you graph this on your calculator and see where it crosses the x-axis, yeah? And of course, you can punch this in on your calculator, yeah? You can do integrals. You don't have to have numbers there. You can have a letter there. And another question they might ask you is, not might, they will, at what time will there be a maximum amount of water in the tank? Because they might give you a function where this is higher than this rate is bigger than this rate, but then after a certain while, then this rate becomes smaller than that rate. So at the very beginning, you know, the water is rising, but then there's a certain time where it declines again. So, of course, how do you find maximum or minimum? What did we learn before? How do you find maximums and minimums? You take the derivative and you make a number line, right? These are all the kinds of questions they're going to ask. And let's just review. How do you take the derivative of, well, what's the derivative of 40? 0. How do you take the derivative of an integral again? Remember? You use the fundamental theorem of calculus part 1. So you make sure the lower limit is a constant, yes, and then what do? You take this t and you plug it in here, so you just get r of t, minus, and then same thing here, make sure the lower limit is a constant, take this t and plug it in here, and then of course don't forget to multiply by the derivative of t, which is 1, and there you go. But doesn't that just make sense that this is the derivative? It's just the difference of the rates, because the derivative is a rate. So it makes sense that the derivative of the amount function is simply the difference of the two rates. Because if this rate is bigger than that rate, then water is going in, right? Overall. We call this the net rate, I guess, in physics, yeah? But if this one is bigger than that, then water is coming out of the tank. Not that difficult. So be ready for that one. By the way, our next quiz, I think, is on next Thursday. I'm not going to ask you these complicated questions yet. We'll save these for the fourth quarter. But I will ask you how much water is in the tank at the end of 10 minutes. So there was a problem last night, right? Just like that. Okay, now, tonight's lesson, we're going to spend 2 nights on it. And it's not difficult. It's just that you guys got to learn how to draw the graphs. You got to find where they intersect. You got to set up the integral, and then you got to do the integral. But it's not that difficult. between a graph and the x-axis. But what if the x-axis is not one of them? So here, let me give you a problem. Suppose you have the graph y equal root x, and then y equal x over 2. These graphs are bounded. So these two graphs bound this region right here. Find the area of this region. That's all you're doing for the next two homeworks, computing areas. So two things you can do. This is where you got to start drawing in the rectangle now. What if you draw the rectangle like this? It's a rectangle of infinitesimal width. Well, how do you find the area of a rectangle? Height times the base, right? What is the height of this rectangle? Well, it changes, right? Because if you draw the rectangle over here, right, the height is smaller, and then over here it gets bigger, then it starts getting smaller again, so it varies. Okay, but so how do we write that in terms of a variable, though? Well, like I told you guys before, look, if this is 2 and this is 5, how do I know that's 3? Top minus bottom, big minus small. And same thing, if it's like on a horizontal segment, if this is 1 and this is 7, how do I know this is 6? Right minus left, big minus small. That way you guarantee it's positive, because lengths cannot be negative. All right, so how do you represent the height of this rectangle? Top minus bottom. Which one is on the top? Top minus bottom, right? Because it changes, right? Over here, like when x is 1, you get a certain height, but when x is 2, you get a different height. So this tells you what it is for any value of x, right? So this is the height of the rectangle. What about the base? It's infinitesimally thin. What do we normally write? Dx. Remember, delta x is a change in x, but when that change in x is infinitesimally small, we call it dx. That's why every integral has to have a d something. And then, if I want to get the area of this whole region, you just add up all of these rectangles. That's what an integral does. An integral just adds up an infinite number of things. Now, so far, we're just adding up rectangles, but later on, we're going to be adding up different things besides rectangles. Okay, so I'm going to add up all of these rectangles from. So what you need to know is you need to know the x coordinate here and the x coordinate there, because we're doing the integral in terms of x. So you got to go from x1 to x2. So what we need to do is figure out where these graphs intersect. Well, this one is obvious. 0, 0. This one might not be that obvious. Now, two things you can do to find the point of intersection. You can set the equations equal to each other and solve it, or you can just guess and check. This one's pretty easy to guess and check. Okay, try 1. If I plug 1 into both of these, do they come out to the same number? What about 2? What about 3? What about 4? Ding! Right? Square root of 4 is 2. 4 over 2 is 2. So 4, comma 2. So don't just automatically, I'm just going to set them equal and use algebra. Yeah, you can. But lots of times you can just find it by guessing and checking, which is perfectly fine as well. So, again, I'm going to add up all of these rectangles from 0 to 4. How come not 0 to 2, Mr. Park? Because you're doing the integral in terms of x. So you have to you go from the x coordinate here to the x coordinate there. And then, of course, the last step, computing the integral. This is easy. What's the antiderivative?
1 over 2.
So this is like x to the half, so what? Make the power 1 bigger, put the reciprocal in the front. And what's the antiderivative of 1/2 x? Oh boy. 1/4 x squared. From 0 to 4. Plug in the top number. Okay, I can do this. You guys got to be able to do this. Justin Lee, plug in the top number.
3/3 times.
Okay, just one number for this one?
16/3.
Okay, 16/3 minus 4, and then of course you guys can plug it in. Now on the AP exam, that's full credit right there. In fact, you know what? I don't want to tell you this because you're going to say, why are we doing all this, Mr. Park? Because this is only AP exam rules. You know, on the AP exam, you can just do this. 2/3 times 4 to the 3/2 power minus 1/4 times 4 squared minus 0 minus 0. That's full credit.
I don't think
On the AP exam. On my exam, you still got one more point to get. So how do you simplify this? You make a least common denominator. 16 minus 12, 4/3. This area is exactly 4/3 square units. Exactly. Yeah, that's why AP exam, it's in some areas I think it's kind of weak, but that's the way to do it. They try to give the students the benefit of the doubt as much as possible. Now, is that the only way to compute that area? And the answer is no. Now, there are some problems where you can do both. See, we drew the rectangle vertically, but sometimes you have to do it horizontally. And then sometimes you have a choice. Like this problem, we have a choice. So what if I were to draw the rectangle horizontally? Well, in that case, then what you gotta do is you gotta change these equations to x equals. So this one's easy. How do you change this equation to x equals something?
2/1.
X equals 2y. And then what about the top one?
Y.
X equals y squared. So here, I'm going to put in the coordinates again, 0, 0, 4, 2. So what is the length of this rectangle? Right minus left. See, when the rectangle is vertical, you go top minus bottom. But when the rectangle is horizontal, you go right minus left. That guarantees it's positive.
Is there ever gonna be like two possible coordinates for the second one?
No. And then, what is the infinitesimal width?
D1.
dy. It's a change in y, but it's infinitesimally small. Call it dy. And then I'm going to add up all of these rectangles from, right? Because if you add up all of these rectangles like this, that's what your calculator does. It adds up like 10,000 rectangles. That's what it does to get the area. But we don't want 10,000 rectangles. We want infinite. So that's what the integral does. And what are the limits going to be? 0 to 2. Because if you do the integral in terms of y, you go from the y coordinate there to the y coordinate there. Now, you can see that it's the same region. So if I compute this integral, I better get the same answer. Well, let's see if we do. What's the antiderivative of this?
Y
Y
squared.
squared minus
1/3
from 0 to 2. Plug in the top number. These are easy. Moroka. Boy, your voice sounds like different people. 4,
minus
8/3 minus 0 minus 0. Make a least common denominator. 12 minus 8. Final answer, survey says 4/3. It is the same answer. You better get the same answer. But of course, you know when you do the problem, you're not going to do it twice, right? Pick the most efficient one. Yeah, but Mr. Park, sometimes you're forced to do it one way. That's right. Question.
How do you know which way to do it?
Well, it depends. Okay, so the first part of tonight's homework, they're actually going to give you the graph, so it's kind of easy to see. But then later on, you have to draw the graph. That, to me, I've been teaching this for over 30 years. That's where students have trouble drawing the graphs. Because those problems require graphs on the homework now. Okay, let me give you an example where you're forced to do it one way. How about, okay, students, x equals y squared, and x equal, okay, I gotta think. 2y squared equations are given as y equals, that's a big hint that you make vertical rectangles. But when it's x equals, then you make horizontal rectangles. So that's one hint. The other one comes from the graphs. Now, can you guys draw these graphs? What is this one? It's a parabola, except it's opening to the right. This one is also opening to the right, except it's thinner, and then it shifted 4 to the left. So, anyway, no matter what, you have to find where they intersect, because that's going to give you your limits of integration. So, what I would say is, if you have a hard time graphing, find where they intersect first, and then you can use those points to help you draw the graph. So how do you find where these graphs intersect? Make them equal. Okay, solve it. So y squared equals 4. So y equals plus or minus 2. So there's 2 points of intersection. The y coordinates are plus or minus 2. How do I figure out the x coordinate? Plug it back into either one. I think this one's easier, yeah? So if you plug in 2, you can get 4. You plug in negative 2, you get 4. So why don't we use this to draw the graph? So 4, 2, and 4, negative 2. Now this one, obviously the vertex is at 0, 0, right? So it's opening to the right, so it's like this. This one though, where is the vertex? 4, which way? Anyway, if you don't know, just plug in 0 for y. If you plug in 0 for y, the x-intercept is negative 4. And it's opening to the right, except it's going to be thinner. It's kind of like this. Like that. So this is the region. Hey, this looks like a Star Trek symbol, yeah? You guys ever watch Star Trek?
Star Wars.
No, not Star Wars, Star Trek, you know, the uniform, never mind. Okay, what is the area of that region there? Now, can you see that, now some of you are thinking, oh, I'm going to make vertical rectangle, but if you make a vertical rectangle, the top equation and the bottom equation are the same curve. So when you go top minus bottom, there's a problem. And not only that, what happens when you get over here?
Okay.
Yeah, there's problems when you make vertical. So that's why you really need to make horizontal rectangles in this problem. Anyway, like I told you before, x equals, that tells you horizontal rectangle. Okay, I don't know if the video is gonna catch that, so let's just do it right here. Okay, so let's set up the integral now. What is the length of that rectangle? Right minus left. Which is the one on the right? Y squared. Minus left. The other one. Mr. Park, what if I don't know? Well, you drew the graph, so you should know, right? But if you don't know, you know what you can do? Is just guess, and if the answer comes out negative, that means you did it the wrong way. Okay, whatever. So that's the length of the rectangle. What's the width? Infinitesimally small. dy. And then I'm going to add up all of these rectangles from negative 2 to 2, right? You go from y value to y value. But we have symmetry here. So instead of going from negative 2 to 2, can't I just go 0 to 2 and times it by 2? Because isn't the region down here the same as the region up there? Yeah. So that, to me, why is it more beneficial to go 0 to 2 and times it by 2? Because it's easy to plug in 0. Because some of you would have issues plugging in negative 2, yeah? And then what about trig values, like plug in negative pi over 3? Yeah, so that's why if you have symmetry, it's better to do this. And then of course the last thing, compute the integral. So the first thing I would do is simplify the integrand. What does that simplify to?
Negative y squared
Plus 4. Okay, antiderivative? Antiderivative easy. Connor Lee.
Negative y to the third plus 4y.
Okay. From 0 to 2, plug in the top number. Okay, this is all easy. I'm not going to even call on you guys. This is an insult. Minus 0 plus 0. can just do it in our head already. Final answer, survey says 32 thirds. That is the exact area of that region. Exactly. So like I said, tonight's homework, I think all the problems, the graph is given, so it's easy. But then when you gotta start drawing graphs, then there's always issues. Okay, one more example and we're done. What happens if you can't figure out the points of intersection by like solving the equations or by guessing and checking? That means you gotta use your graphing calculator. And you gotta become really proficient at this, because you're gonna get a lot of these on the multiple choice part. Well, even on the free response as well. Okay, let me think of something. Okay, what if you think of a graph that looks like this. Y equal cube root of x. And then how about a graph that looks like this? Y equal, x to the fourth then. Find the exact area. Well, you're not going to be able to find it exactly. So use your calculator to find, wait a minute. That's a bad problem. I'm going to change it, okay? I don't like this. We can keep the x cubed. I want something where you can, how about a sine graph? Yeah, sine, yeah, there we go. This is a sine curve. Y equals sine. How about x over 3? Yeah, what the heck? Just put a 2 there just for funsies. Alright. Find the area of that region, and if you use your calculator, of course, you got to give 3 decimal place accuracy. Now, the hint is y equal. If the equations are given as y equal, that's a hint that you should do vertical rectangles. Although, actually, in this problem, I'm not sure. Anyway, we'll just go with it. Maybe you could do horizontal, but why, right? So what's the length of the rectangle? Top minus bottom. Which one's on the top? Top minus bottom, multiplied by the infinitesimal width. So that's the area of that one rectangle. So to find this entire area, I add up all of these rectangles from here to here. So, well, that one obviously is 0. How do I find the x-coordinate where they intersect? That's where you gotta use your calculator, okay? So, because there's no way you can solve these equations algebraically, so you have to use your calculator. Okay, I'm gonna do it then. You guys have your app up?
No.
Let's just get it on the screen so I can show you. Some of you forgot. Okay, so we gotta go to apps, function. So we punch in the function. We gotta get rid of this. Make sure you're in radian mode because there's a trig function there now. So, the first one, hey, I thought I cleared it. Shift, clear, okay there. 2 sine x over 3. 2 sine x over 3. Right arrow, enter. Okay, the second function is x to the 4th. X raised to the 4th. Right arrow, enter. And shall I just press the plot button, hopefully I see something? Yeah, I guess that's okay. So we need to find that point of intersection. Remember how to do it? Move the cursor there, press your finger somewhere near there and go menu, function, which one? Intersection. Boom. I guess you can pick either one, and there you go. So we need that x-coordinate. Now, remember, do not use a rounded value in another computation, because you might get off. If you are off in that 3rd decimal place, you're going to get the problem wrong on the AP exam. So you got to use all the decimal places. So Once your calculator computes this point here, this number here with all its decimal places is stored in X. The Y coordinate with all its decimal places is stored in Y. See 0.86950? So like if I go to the home screen, let me just show you. If you go to the home screen and you punch in X and press enter, see 0.869 got all the decimal places. So you can store this. You see this here, store, right there? So what I like to do is I store it and pick a letter from A through Z. I'm going to store it in A, so alpha A. Enter. So now whenever I punch in A, the calculator will automatically plug in that number with all the decimal places. Now of course with your calculator, you can just copy and paste too, right? Copy and pasting works as well. Okay, so now let's punch in the integral. So remember how to get integral? You go to the template button here. Template. There's the integral right here. So here, select the integral and just punch it in. So the lower limit is 0. The upper limit is A, so alpha A. The calculator is going to plug in that number with all the decimal places. And the integrand here will be 2. Oh! Never mind, we'll just do it. 2 sine x over 3. Actually, because we punched it in on the calculator, we could just go y1 minus y2. But I don't know how to get that on yours. But we'll worry about that later. Minus x raised to the 4th power. Right arrow. Oh, we gotta punch in. Oh no, not right arrow there. Hey, how do we get rid of that parentheses? X raised to the 4th. Change that to a dx. I think you still gotta right arrow it, you know. Press enter. Boom! And then now you round off your answer. 0.151. Because I think on the homework there's quite a few problems. So when you write your integral on the AP exam, what was the number again? 0.89 what?
You have to write all the decimal
No,
places for that?
when you're just writing it, you can just round off to 3 places.
Okay.
But when you use it, you're going to use all the decimal places.
So how do you do that from here, like, get all
Just
the
store it.
decimal places from here?
I just showed you.
I wasn't paying attention.
You wasn't paying attention.
Not to that.
Okay, you see that number? Once you compute this, that number is now stored in X. Okay, so go to the home screen. Try punch in X. And then enter.
Oh,
Okay.
that's pretty cool.
And then I'll store it. See it on right there, store?
Yeah.
Store it in like A, B, C, D, or E, whatever you want. Anyway, I need 0.8. So if you round it off, it's actually 0.870. But then when you punch it in on your calculator, you gotta use all the decimal places. So the answer they want is, I forget the number, 0.151. 0.151. Now, again, so when you, on the AP exam, a typical problem like this would be worth 3 points. So you get the integrand correct, you get 1 point, you get the limits of integration, you get another point, you get the final answer, you get the 3rd point. That's how it's usually broken down. If you are off in the 3rd decimal place, it's wrong. You're gonna lose the whole point. You'd be surprised, you know what, great AP exams, you'd be surprised how many students are not only off in the 3rd decimal place, some students don't even give 3 decimal place accuracy. It's like, I don't know, either they don't read the directions or their teacher didn't coach them. You have to have 3 decimal place accuracy. So some students just write 0.015 because they don't know what to do. That's wrong. Because they tell us, when you grade the papers, if they don't have anything there, you assume it's a 0. So therefore it's wrong, right? But don't worry, you'll be well coached. All right, any questions on any of this? Or there's not going to be be any more lecture for it. We're gonna spend 2 nights on this, you just gotta get better at it. Like I said, tonight's homework, they'll give you the graphs. The following homework, you gotta supply the graph. Alright. Oh, why don't we just leave the camera on? I got a game, let's play one game, and then we'll go home. Except we still got the rest of the school day to do. Well, since we got Super Bowl on Sunday, I just looked it up this morning. This is not it.
Over here.
Here,
Top Super Bowl commercial.
best Super Bowl foods.
Oh, what?
If you have a party, like what are the best Super Bowl foods to have at your party? If you have, but nobody's gonna have a party this year, right?
No.
Okay, who won? Did we play yesterday?
I'm not gonna do it.
Who won, boys or girls?
Most likely
My
girls.
girls.
Okay, boys go first. Oh, the Valentine's Day one. Was it the? Okay, let's start with this one.
We were close.
Boy. Yeah, just go down here. Boy. Best Super Bowl foods.
Pizza.
Pizza, number 3.
Glizzies.
Girl. Nachos, number 2. Boy,
Wings.
There you go.
1. Girls. Popcorn.
Where's the list? 25.
Well, it might be on the list, but it's not on the top 20. So 25. Boys.
French fries?
French fries. Not on the list. Girls.
Are nachos and chips counted as the same thing?
No.
Chips,
Chips. What kind of chips?
potato,
Potato chips.
You like drinks too? Oh yeah, is there drinks?
No drinks on this one.
Just think of the most
Sorry,
generic-
no potato chips.
Tortillas.
That doesn't seem right. There's gotta be potato chips at a party.
Over to the stupid movie.
Burgers.
Burgers.
Yeah, there you go. Mine. 5.
6. Burgers, 6.
Glizzies.
Girls. Girl.
hot dogs,
Hot dog.
Golden glizzies.
5.
Hot dog, 16.
I'm not that high.
Boy. Boy. No matter. Okay, boy.
Steak.
Steak.
What? Yeah.
No, not on the list.
Without boy.
Well, maybe if it's an outdoor party, huh?
Yeah, that's what I was thinking, like a barbecue.
Okay, girl. Girl. Henry.
This is hard. The top ones are easy.
mac and cheese,
What?
mac and cheese.
Mac and cheese.
Oh.
Not on the list. Boy.
Chili.
Chili. That's gotta be here.
No, it's a bad list. Delete it. Throw it away. That's tailgate food.
I know that chili should be here, but you know what? It's not. 25. Girls.
Sandwiches.
Sandwiches. I think I remember it was like 20 something, like you know those big sub sandwiches, but it didn't make the top 20. 25. 118. Boys, we're gonna go back to the moral go first.
Yeah.
Okay.
Fried chicken and wings are like the same thing, right? Or
No,
fried chicken.
not on the list. Girls.
Like dip?
Okay, you gotta be more specific.
Like a type dip specifically?
Yeah, got like,
Oh, like,
I don't wanna say, but got like at least three different types of dips here.
like the bean dip, I guess? Or like the the 7-layered one.
7-layer dip number 11. Okay, so we're nearing the end, right?
Yep.
Only one more, okay. Lead.
And salsa.
Okay, salsa then. Salsa is 5.
Oh,
Ooh.
it's just all the dips, so silly.
And girl,
Spinach and artichoke dip.
that should be,
Guacamole.
that should be here, but you know what? It's not. 25,
So Justin,
154.
easy winner.
Oh.
Hey, look, the boys won this time.
Oh, yeah.
Oh, wait a minute. Somebody said potato chips.
Yeah.
Justin.
Wait,
No.
wait, this is a revised score.
Then not.
One of the girls.
It's right there. I can't believe I didn't see it. So,
Emily.
did I say not on the list?
Yeah.
Yeah.
So this is actually 4, so you gotta subtract 21 then. 133. Oh!
Yeah.
Potato chips number 4. How come I can't see that? Sliders number 7. Pigs in the
That's a
blanket.
burger.
Guacamole.
Mini hot dog.
Jalapeno poppers.
Oh.
Mozzarella sticks.
Oh.
Chicken tenders.
Oh.
That kind of counts as fried chicken, yeah?
It is
It's like Dave and Buster's.
No, it doesn't. Fried chicken, that kind of implies you got the bone. That's why, right? Tortilla chips, quesadillas, corn chips, tacos, baked potato skins, and number 20, brownies. All right, we are done. You guys got like 13 minutes left.